In lesson 4, we're going to look at the most complicated type of projectile we'll come across in terms of in its simplest form, it becomes the most difficult type to calculate, and that is a projectile which is launched into the air from a height. So let's look at an easy method to calculate these types of problems. As we've done previously, we're going to draw a line that goes from the ground to the max height of the projectile. You can see now though that this is not the midpoint of flight, so we lose some options here in terms of how we're going to calculate this, as we've done in our previous projectiles where they landed at the same height. So from this point, our best option is to break this problem into two, or we'll break the projectile's flight into two. The section on the left of the dotted line should be solved separately as a straightforward projectile on a flat surface, but you finish your calculations at the max height. And the second section can then be solved as a horizontally launched projectile from a height. Then you add your calculations together and you get a final result. Let's take a look at an example. The projectile is fired at 40 degrees to the horizontal from the top of a cliff 100 meters high. Its initial speed is 49 meters per second. So once again, we can very easily determine the initial velocity because it's given to us, and then very simply the ux and uy using our trig equations. From here, like we've done previously, we're going to determine a time of max height using v equals uat, where vy is 0 at its max height. So we can determine that at the ty, the time is 3.21 seconds. Now obviously we can't do the doubling trick where to get the t total because we know it's not double anymore. But from here we can determine the max height using delta y. And we'll get a value of 50.61, but we also have to add in the 100 meters, which is the height of the cliff. Now that we know the height of the cliff, we can determine how long it will take to fall using the delta y equation, but it needs to be a minus value because it's going in the downward direction. And because it's at this point the vertical velocity is 0, we can put that in and we'll get a nice neat value of 5.54 seconds. And now we can get a total time value by adding the two together, and we get 8.75 seconds. Now that we've got the total time, we can put it into our delta x equation, and boom, we've got the total displacement, which is 328.44 meters per second. Obviously, once again, you can use this sort of method to solve any of these type of problems, but sometimes you're given some things and some others that you're not given. So you might have to do these equations in a different order, but they're all pretty much the same thing. So good luck with these type of questions. They are the hardest, but once you get practice with these ones, you'll find that the other type that we've previously done are a lot easier.